Hi boys and girls, this is our read aloud for this week's homework. Telescope captures most detailed pictures yet of the sun. That reminds me of like the telephone and other words. So I'm gonna go ahead and box that. Scope seems like something that you can see through. So let's say telescope, maybe something that helps you see things that are far away, like the telephone helps you hear things that are far away. The inner solar telescope's images show the sun's turbulent surface in new detail. Turbulent. I'm going to circle that. Based on the picture, that doesn't look like super good, so I'm going to put that that's probably a negative word. The striking images reveal a surprising level of structure hidden within the churning plasma exterior. A previously hazy impression of the sun's patchwork surface has been brought sharply into focus for the first time. These are the highest resolution images of the solar surface ever taken, says Thomas Rimmel, the director of the Inouye Solar Telescope Project. What we previously thought looked like a bright point, one structure, is now breaking down into many smaller structures. The telescope's 20-mile resolution is more than twice that of the next best solar observatories. Columns of plasma show up as bright spots. The images reveal the sun's surface to be speckled with rock-like structures, like nuggets of gold. Ooh, I see a like there. That's a simile. So it looks like we're comparing the sun's surface to having nuggets of gold. So these little rock-like structures on the sun's surface look like these nuggets of gold, each about the size of France. Wow, that seems really big. Rising columns of plasma, gas that is superheated to almost 10,800 degrees Fahrenheit, show up as bright spots at the center of each grain. Each is an epicenter. The violent release of heat from the sun's interior to its surface. As the plasma cools, it descends back below the surface via a narrow, shadowy channels between neighboring granules. I'm going to go back and I'm going to try and make connections. So let's see. I see a telescope here. So my first connection is going to be I have observed the sky with a telescope. And I'm going to use the word observed instead of seen because that's fancier academic vocabulary. Let's see. I'm also going to ask a question down here where it talks about where it talks about that there are observatories, but they're not as good as this one. And I'm going to put where are the other observatories, are places that hold buildings that hold the telescopes. Where are the observatories located that also have really good telescopes? That seems like a cool place to visit. All right, turning the page. We're on that second paragraph. This close level of detail will help improve understanding of the sun's behavior. Scientists will hopefully be able to predict the sun's activity cycle more accurately. The U.S. National Solar Observatory's $344 million telescope features a 4.5-yard mirror, the world's largest for a solar telescope. The instrument is located at the 10,000-foot summit of the Hikalea volcano on the island of Maui. Oh, so I know that's in Hawaii. So this telescope is in Hawaii. Maybe my connection could be I want to visit Hawaii and see this telescope. That would be really cool. Heat intense enough to melt metal. Valentin Pilot, the director of the National Solar Observatory, described the telescope, which had been under construction since 2013, as a formidable technological achievement. I'm going to circle formidable. I know that this word able to formid, it seems like a negative word, so maybe almost like a scary technological achievement. A major challenge was maintaining the telescope's primary mirror at the right temperature while it looked directly at the sun. Any temperature change causes air turbulence that would ruin the image quality. The heat is intense enough to rapidly melt metal at the mirror's focal point. Each night, a swimming pool's worth of ice is emptied into 8 tanks. During the day, coolant is routed through the ice tanks and distributed through the observatory by 7.5 miles of piping. More than 100 air jets are also positioned behind the main mirror. Incoming light from the sun is deflected from the primary mirror into a chamber of mirrors that sits below the observatory's dome. Here, the light is bounced from mirror to mirror as it splits between various instruments. The observatory's full suite of instruments, which will allow scientists to measure the magnetic field from the sun's surface up to its outer atmosphere, will come online later this year. The bright features in the image are the foothills of magnetic fields that extend all the way up into the corona and beyond, said Rimmel. With the additional instruments that will come online in the next 6 months, we'll be able to measure the magnetic fields from the surface all the way up to 1.5 solar radii. That's a really technical sentence. So I'm going to move on for right now, and I'll come back if one of my questions ask me about it. I'm also going to try and make a connection here. Some of you have been learning about the solar system in science class, and I've been reading about the sun in 3rd block with one of my groups. So maybe you've been learning about the sun during Mr. Chris' class or Miss Ford's class. Maybe you're reading about it with Miss Barrick during 3rd block. Resolving long-standing mysteries about the sun. The observations could help resolve long-standing mysteries about the sun, including the strange fact that the corona, or the sun's atmosphere, so the corona, what it talks about up here, is the sun's atmosphere. All right, so that helps me, because I know the atmosphere is like the sky, so it's like the sun's sky, is heated to millions of degrees when its surface is only about 10,800 degrees Fahrenheit. Understanding the physics of solar flares and coronal mass ejections or bursts of plasma could also significantly improve the ability to predict space weather. Such solar events can render GPS systems unreliable, take down power grids, and knock out communication channels. So this is one of the reasons that I've been thinking in my head. I'm like, wow, why are we spending so much money, $344 million on one telescope? But this is to make sure that we can keep using our GPS and that our power grids are working and make sure that our communication channels are working, things like radios and those sorts of things. So this is really important. So you might want to make a connection here if you haven't already, or ask a question maybe about how the sun helps or hurts GPS. All right, last little bit. The release of the images comes as NASA's Parker Solar Probe makes observations from the edge of the sun's atmosphere. Next week is the launch of the Solar Orbiter mission, a European Space Agency NASA collaboration. So we're getting to see all of these images because NASA really wants us to pay attention when they go into space this time. Number 1, read the paragraph from the section, Heat Intense Enough to Melt Metal. Incoming light from the sun is deflected from the primary mirror into a chamber of mirrors that sits below the observatory's dome. Here, the light is bounced from mirror to mirror as it split between various instruments. The observatory's full suite of instruments, which will allow scientists to measure the magnetic field from the sun's surface up to its outer atmosphere, will come online later this year. Which of the following can be inferred from the selection above? So this seems to be talking about how there's a lot of heat going into mirrors and that the observatory isn't fully completed yet. A, the findings from the telescope will save many lives. Does it say anything about saving lives in there? If not, cross it out. B, scientists have learned more than this telescope than previous ones. Does it say anything about learning more than old ones? If not, cross it out. C, the full potential of the telescope has not been revealed. Does it say that maybe we have more work to do? Full potential, that it hasn't been fully completed. If it talks about that, put a check mark. If it doesn't, make an X. D, the observatory was funded by the government. Does it say anything about funded means money? Does it say anything in that paragraph about money? If not, put an X. 2, read the following statement. A more in-depth study of the sun and its atmosphere can help prevent certain problems on Earth. Which sentence from the article best supports the statement above? So which one tells us that learning about the sun can help us prevent, can stop before they happen? Remember, a synonym for prevent is precaution. Can stop before it happens problems on Earth. A, scientists will hopefully be able to predict the sun's activity cycle more accurately. Does that tell us that knowing about the sun can help us stop problems on Earth? B, any temperature change causes air turbulence that could ruin the image quality. Does that sentence tell us that learning about the sun can help us solve problems on Earth? C, incoming light from the sun is deflected from the primary mirror into a chamber of mirrors that sits below the observatory's dome. Does that one help us learn about the sun? D, such solar events can render GPS systems unreliable, take down power grids, and knock out communication channels. Does that tell us why studying the sun helps us stop certain problems on Earth? Number 3, what is the meaning of the phrase patchwork surface as it is used in the following sentences? A previously hazy impression of the sun's patchwork surface has been brought sharply into focus for the first time. A place where some things have been deposited. So let's put that in where it says patchwork surface. Let's use our substitution strategy. A previously hazy impression of the sun's place where some things have been deposited, have been left, have been brought sharply into focus for the first time. B, a previously hazy impression of the sun's area of something made by multiple parts has been brought sharply into focus for the first time. C, a previously hazy impression of the sun's huge swirling mass of something has been brought sharply into focus for the first time. D, a previously hazy impression of the sun's large group of stars near each other has been brought sharply into focus for the first time. Also think about with patchwork, that reminds me of a quilt, or when someone patches a pair of pants by putting another piece of cloth on there. So maybe there's more than one part to the sun's surface. 4, the section resolving long-standing mysteries about the sun includes phrases such as long-standing mysteries and strange facts. How do these words contribute to the tone of the article? So how do they help or hurt the tone of the article? Remember, the tone is how the author feels. A, they add suspense surrounding potential future discoveries. So do the words mysteries and strange add suspense? B, they emphasize the scientific significance of the findings. C, they increase the overall optimism surrounding future discoveries. So optimism, like optimal, that seems very good. So long-standing mysteries and strange facts. Mysteries and facts seem to be negative, so I'm not sure about C. D, they explain the scientific understandings of the findings. Do these words help you understand science? So go back and decide between A and B, which one you think. Listen to them again if you need to.